Hey everyone, let's go ahead and go over section 7.4. So we are going to start using those established trig identities to prove other identities that we haven't seen yet. So we're going to still use the quotient identities, the Pythagorean, and the other ones that are typed there on your notes. But now we're going to start to establish other ones. Okay, so the first one, 1 minus sine squared all over 1 minus cosine of theta is equal to negative cosine of theta. So when we got to, when it tells us to establish or to verify or to prove the identity, we need to choose one side and one side only and work with it until we get the other side as an answer. So you can only work with one side at a time. You can't do both sides all the way down. You can't move things from side to side. You gotta just pick a side and work with it. So when you're trying to decide, which one do I want, you normally go with the one that looks the worst, because that's actually the one that you can do the most stuff with. You could choose this side over here, but you're gonna have to be really creative to find a magical step that's going to turn this into this. So let's start with the left-hand side. And you always want to denote which side you chose. So left-hand side. So let's go ahead and play around with this. So we're going to leave the 1 alone. We're going to leave the denominator alone. And we're going to do something with that sine squared. So sine squared, there's an identity that we can use, and we looked at it in section 7.3. That's that Pythagorean identity again. And that's kind of nice because we got rid of the sine of theta, we got rid of that function, and we don't want it in the answer at all. So it's nice that it went away. And the other reason why it's nice is because now the numerator, that 1 minus cosine squared, it'll factor into 1 plus cosine of theta times 1 minus cosine of theta. So now the 1 minus cosines can cancel. And the negative that's sitting out in front, it'll distribute to everything that was left over, everything that we didn't cancel out of the fraction. So that'll go with the 1 and the cosine. And it gives you negative cosine as a result, because the 1's cancel out. And now you have what you were trying to prove. So when I grade these, what I'm looking for is the stuff that's in between. So tell me where you start and then do all the math, and you're gonna end up with this. So I'm not looking at the last step because I know you know what the answer is. I just wanna know about everything in between. Is your math correct? So whether it takes you 2 steps or 5 or 18, hopefully not that many, but whatever you do, that's what I'm gonna look at. Because a lot of times there's more than one way to go. Okay, let's go ahead and try the next one. Cosine of theta plus 1 over cosine of theta minus 1 equals 1 plus secant theta, or 1 minus secant theta. Sometimes when you have to establish an identity like this, there really isn't like a real clear side as to which one looks worse, because they're both almost the same. But this one, the right side, it's actually a little bit more worse than this one, mainly because I can use an identity with the secants. But if you can't decide which one looks worse, then just pick one and go for it. So let's work with the right-hand side, and we're going to choose another identity to use here. So secant, we can turn it into 1 over cosine. And if I switch this secant, I'm also going to switch the other secants in the problem too. because you don't want any secants in your result. So we've changed it into a fraction within a fraction, but we've seen how to simplify those before. So we're going to multiply everything by the common denominator, or that cosine. And that will clear out any little fraction that's in the big one. So this cosine, let's distribute. So multiply to the 1. Multiply to the fractions, so they actually cancel off. And then the same thing in the denominator. And there you go, you got what you wanted to prove. So sometimes they take 2 steps, sometimes they might take 3 or 4, sometimes 5 or 6. It just depends on, you know, what it is that you're trying to prove. So we're going to skip to example E. So I'll let you look at C and D on your own. And example E, this one you should probably have a good idea as to which side looks the worst, and it's actually the left. So 1 plus sine over 1 minus sine minus 1 minus sine over 1 plus sine. And it's supposed to equal 4 tangent theta secant theta. So let's go ahead and choose the left side. That one definitely looks more, or looks worse than the other side. You could choose this one if you wanted. You just have to be more creative with it. Whereas this side is going to be more direct. So what could we do with that left-hand side? So when you're looking at this stuff, you know, is there an identity that can apply? And with this one, there really isn't. Nothing squared. There's no reciprocal identity that would be useful. So there really isn't an identity that applies, but there is some algebra. You're subtracting 2 fractions. So we know how to subtract fractions. We just need a common denominator. So here's your common denominator, 1 minus sine, 1 plus sine. Now we can figure out the tops. So this 1 plus sine that's up here, it's going to get multiplied by another 1 plus sine. And then we have the minus, so minus, and the 1 minus sine of theta that's already in the numerator, we have to multiply it by something, and it's this, the other 1 minus sine. So now what's in there that we could actually do? Well, it looks like we could do some more algebra. So we have a whole bunch of things, like quantities are multiplied together. So let's FOIL them out. So 1 plus 2 sine theta plus sine squared theta. And in this set, we're going to FOIL it as well. But when I do that, I have to remember there's a negative sitting in front. So I can FOIL it, but then the negative, it's going to distribute. It'll flip all the signs. So let's FOIL and flip all your positives and negatives. So we end up with a negative 1 plus 2 sine theta minus sine squared theta. And then the denominator, we had so much fun foiling on the top, so let's go ahead and FOIL the denominator so it doesn't feel left out. So you have 1 minus sine squared. And now we've got this giant mess, but sometimes it has to get bigger. You have to get a giant mess so that way you can start to reduce it. And in fact, it does. Because your 1's cancel out. your sine squareds cancel out. And then just add up what you can, which would be the 2 sine of thetas. So 4 sine theta. And your denominator, we can turn that, we can actually make that simpler. You can turn it into something else. And it's that same identity that we have used before. It's a Pythagorean. So 1 minus sine squared becomes cosine squared. And the cosine squared, we can rewrite that too. We can kind of break it apart. That's just cosine times cosine. And then I can bust apart the entire fraction. So I can take the 4 just on its own. The sine, I'm going to take it and just stick it over one of the cosines. But I still have a cosine left over, and it's still in the denominator, but I'm just going to put it in its separate fraction. Well, I can't just leave the numerator blank. Anytime you have a blank numerator or denominator, there's really a 1. So we can leave the 4, and now sine over cosine, that's tangent. And 1 over cosine is secant. And hey, you ended up with what you wanted to prove. Okay, so the other 2 examples I'll leave for you guys to look at. The key for these things is to try them. You know, don't get intimidated by the problem. You guys have all of the skills necessary to solve these. You know all the algebra, you know all the identities that would apply with these. So just give them a try. And don't be afraid if you get it wrong or you get stuck. You just gotta try stuff out. You need to know what works as well as what doesn't work. That's really important, because then you know not to do it again. And you kind of get you start developing skills, and you start to kind of get a feel for what to look for. Common denominators, foiling, factoring, you know, when that stuff applies, when it might not. You just gotta try them out. Nothing's gonna happen to you if you get the ones in the homework and the notes wrong. You know, your desk does not explode. That only happens when you divide by 0. So just give them a shot, just try them out. Okay, so that's section 7.4.